So good day. Let us kick this presentation off with a discussion of Mr. Fahad Al Atiya in TED about Qatar, a country with no water. Mr. Fahad described Qatar as a country with no resource. It had no water, no energy until they discovered oil. After the discovery of oil, look at this. The water consumption grew. From zero, it became 430 liters per capita per year, and according to him, it is among the highest consumption of water in the world. So how did the country like Qatar, who has 74 millimeters of rain per year, have a growth of 15%? Mind that Qatar has no natural source of water. This is because of the desalination plant. According to Mr. Fahad, this is Qatar's river and lake. But this technology can only produce 2 days of potable water reserve. For a country that has no water, this is a small amount of reserve. So to say, for a country like that, do you think wasting water is a viable option? No, it is not. And the College of North Atlantic Qatar's engineering department is wasting a lot of water in their process of operating the boiler. And this is a problem.
Thank you all for watching this presentation that me and my partner presents to you. Our capstone project is to design and simulate a condensate return line for the boiler in building 9141 in CNAQ. Again, my name is Pablico and my partner Alexander Mercurio, and let us begin with the presentation. The outline of this presentation, we would talk about the background, the problem statement, existing solution, and we would also talk about project statement, objectives and criteria, our methodology, conclusion, the recommendation, and the acknowledgements, and lastly, the references.
The background. The College of North Atlantic Qatar houses a fire tube boiler. This is the fire tube boiler that CNAQ owns, and this is what it looks like inside. It produces steam for various processes within the college, like the aerator, steam turbine, and the process automation trainer. The problem statement. The boiler runs on an open steam cycle. We will discuss that in the later slides. But this cycle drains condensate out of the system after getting used. So water, chemicals, and energy are wasted in the operation of the boiler. In average, about 3.06 gallons per minute or 183.6 gallons per hour of condensate is wasted. That is equivalent to 1,100 gallons per semester and more than 3,000 gallons per year. For the existing systems, right now the boiler, as mentioned, runs on an open steam cycle. Our aim is to turn this open steam cycle into a closed steam cycle by adding a condenser and a pump.
For our project statement, our project consists of four major parts, where the first one is to design the return system using sketches. The second is to simulate the design. Third is to specify the equipment that we would use. And lastly, we would provide a maintenance plan for the design project.
The objectives and criteria. The first one is that the tank must have a specific amount of condensate, and our measurement would be minimum of 20 liters and a maximum of 40 liters. This will be measured by level sensors. The second objective is to heat the condensate up to a specific temperature before it enters the deaerator. There should be at least 90 degrees Celsius, and it will be measured by thermosensors. The third objective is to make sure that the condensate has a similar chemical characteristic as the feed water. We will measure that by using a pH alkalinity test. Fourth one is that there should be a reduction of cost of at least 40%. We will measure that by um, measuring the amount of resources used without the design and with the design.
For our methodology, we divided our project into six parts. The first is to sketch of the project. In this, We looked at all the existing system inside the boiler room, which is a boiler and the steam turbine, and our project is based on the existing system. For our project, we took two iterations of the design, and with all of the sketches, we used a software called Microsoft Visio to provide you a piping and instrumentation diagram, which is also known as PNID. So for this, we have total of 5 sketches. The first sketch consists of 4 tasks. The first task is the looking at the feed water line. The second is the deaerator line. The third is the boiler line. And the fourth is the atmospheric line. The second drawing, which is the steam turbine line. We studied the steam turbine flow and looking at this specifically where the condensate is collected into the open drain tank. It then drains out all the condensate that is collected in the drain tank and which is considered as waste. So now, looking at our project design, we want all of this condensate in the open tank be sent back into the system, creating a closed loop. Here it enters a series of equipments and eventually will return back into the deaerator and back into the process. Our next our next sketch is a modification of the first design, where we decreased the number of heater into one, and also we used a process of automation to control all the equipment. And finally, our final project design is a more efficient way to return back all the condensate into the system, where we used less equipment to reduce the cost, and also the use of automation process. So our next part of the methodology is to run the boiler. Running the boiler is authorized by the boiler operator, Mr. Brent Valen, and not just the boiler were used, also the steam turbine, and so that we could take measurements of the condensate tank level. And to present you, all of these experiments will be will will have an outcome of the calculations that we would use for the project. Here, the process of our experiment begins with the boiler. The boiler heats up the water until it turns into steam. The steam is then sent into different parts, such as the steam turbine. And in the steam turbine, the steam is used to generate electricity. Once the steam turbine is done with the steam goes back into condensate, which is a liquid form, and it will be collected into the tank. This tank is then measured by using a measuring tape, and we would take all the dimension of the tank. In order for this to happen, we would have to start the steam turbine to start collecting all the condensate into the tank. The next step is to measure all the water that is entering the tank. First, we measured the fuel level before starting the steam turbine, and it's not shown in the video. However, we started by letting the tank fill with the condensate for 1 minute. This condensate is then measured using a measuring tape, and we repeated this step until the 5th minute. So it has 5 intervals. And now we drain the tank and we measure the fuel level of the tank to see the fuel difference between operation and non-operation. After obtaining all the data that was collected from that experiment, we could actually calculate the volume that was currently in the tank per minute. And so that once the volume is calculated, we could measure the volumetric flow rate of the water entering the tank. And the outcome is 193 centimeters cubed per second. And it's also the same as 3.06 gallons per minute. And this calculation will be used in the further specifications.
So for the third methodology, we had the process of simulating the design. We used the information from the volumetric flow, equipment specification, and the project design in the process of simulation using Aspen HYSYS. And through this, we were able to achieve the simulation specifications, which will be used for determining the equipment involved in the design. There are three steps to this process, and the first one is to digitize the design. This is a simplified version of the simulation. This is actually the second iteration, and it is simplified into just the return system. The second is to run a simulation. This is the interface of the simulation software Aspen HYSYS, and you can see that it is currently active, which means that the simulation is active. The third one is to collect information from the simulation. If you go back to this, you can see that there is an option for workbook. This workbook is going to show this, and the blue lines represent values that we obtained from running the boiler, and the black text are products of the simulation. The fourth methodology is to determine the equipment involved in the design. We use the simulation specifications to determine them, and in order to choose an equipment, we compared three of the same type and used specifications and cost as basis in order to choose the equipment. The first equipment is the pump. The MSV121P will pump condensate from the tank into the system. The second is the pipe diameter.
This pipe diameter is calculated using the volumetric flow rate that was calculated earlier while running the boiler. We decided to choose Schedule 40 steel pipe diameter, steel pipe.
The third determined equipment is the valve. There are two types of valves required for this project. The first one is the flange stainless steel swing check valve. This valve will prevent backflow of condensate. The other type of valve is a isolation valve, which will be used to isolate the equipment, and the stainless steel flanged ball valve will be used. The next set of equipment will be considered as heaters and sensors. The first one will be the heater. The heater will heat the condensate before it enters the deaerator. This equipment will be responsible for objective number 2, which refers to the temperature. The last equipment involves the sensors. There are two types of sensors required for the project. The first one is the level sensor. This will detect the condensate level in the tank, and it has a built-in controller which will be used in order to control the pump. Now, the pump that was selected in this project has a larger volumetric flow, and since that would cause to an even faster rate of depleting the water inside the tank, this sensor will be responsible to turn it off when it reaches the minimum amount of volume. The second is the bimetallic temperature gauge, which will sense and indicate the temperature of water or condensate before it enters the heater and after it exits the heater. The fifth methodology is the tabulation of bill of materials. So we use the information from the determined equipment and their prices in order to tabulate them in the in Microsoft Excel. The output is a bill of materials. This is a summarized bill of material, and as you can see here, we have a total amount of 6,226.18 reals. The last methodology is to develop a maintenance guide.
Developing a maintenance guide is then done after all of these method is completed. So all of the equipment that was specified will then be examined, and so that to create a maintenance plan, the help of our technical uh, advisor is needed to identify which maintenance would be used, and so that we would provide a maintenance plan guide. Here is a summarized maintenance guide that we came up with, and this uh, considers all of the equipment that was used in our design, and it says the function statement of the equipment, the failure mode, the type of maintenance that would require, and when it fails, what maintenance should be performed. Moving on to our conclusion, we compare the planned criteria to the actual criteria, and our first objective was to keep the condensate in the specific level, and our plan is to keep it between 20 to 40 liters. And our actual criteria was slightly different. This is because the pump that we chose for this design have a much larger volumetric flow than the incoming condensate water, where if the level exceeds 58 liters, the pump will operate, and if the level reaches 0 liters, the pump will shut off. The second criteria is to raise the temperature of the condensate at least 90 degrees Celsius. We meet this criteria by increasing our temperature of the condensate into 95 degrees Celsius, and this would benefit our project to decrease the thermal shock that would occur in the system.
The third objective is that there should be at least 80% similarity in terms of chemical composition between the condensate and feed water. And after a research was done, we concluded that there will be no changes on the condensate and feed water. uh, we determined that this objective has been achieved. The fourth objective is that there should be a cost reduction of at least 40%, but we will have no process, or we have no way of determining that. So we just considered the reduction of cost by returning all of the resources used on the steam turbine into the system. And we were able to achieve that through simulation. As for the recommendations, the first one was to use instrumentation software to improve instrumentation of the design. Second is to manufacture the equipment with determined specifications. An online chemical treatment should be added to further treat the condensate in case of acidity increase.
The second case of recommendation is the methodology. The first is to determine the schedule of the resources for proper project management. Also, studying the courses needed for the capstone 2 ahead of time.
And lastly, we would like to acknowledge Mr. Sean Sugheb project, and Mr. Brent Valen, Mr. Jamal Kurdi, Mr. Shabir, and our friends and family. Here are the references that we used for our presentation. And I am Alexander Mercurio,
My name
and
is Pablico.
thank you for watching our capstone presentation.